Latitude Media, podcast at the frontier of climate technology.
And so was there a moment where you were asking yourself, is this going to happen or is this all going to come crashing down?
Yes. But I think the question was, is this worth it? Is this worth the toll on the team? Is this worth the capital that we've raised? We look around and there aren't a lot of first-of-a-kinds. There are very few climate tech companies who can say they're operating at commercial scale and that the customer is accepting the product. And it's a lonely place to be the only one and not know what's on the other side in the thick of things.
In 2023, Shreya Dave was in the middle of building a large filtration system. But not just any filter. This was a first-of-a-kind membrane designed to replace energy-intensive industrial evaporation at a paper mill. It was her company's first commercial project, and they were racing against multiple clocks, including the weather. Winter was coming.
We were building in Grand Prairie, Alberta. I think the average snow load is something like 6 or 7 feet, and you cannot break ground at any other month except for June to September or October because the ground's frozen. And we knew that if we didn't break ground in June, then we were probably not going to be able to finish the project in the timeline that we needed to. And if we delayed the project, then we were going to need to raise more capital in order to manage our burn to complete the project.
And as the complexity of the project grew and deadlines neared, Shreya faced a familiar feeling for many founders: self-doubt.
I think that there were moments where I wasn't sure if we had the stamina to finish the project. I wasn't sure if we could get everybody on the same page in the time frame that we needed to.
I'm Laura Pierpoint, and this is The Green Blueprint, a show about the architects of the clean energy economy. We've already invented most of the solutions needed to decarbonize the global economy, but many of those technologies are not yet commercial and need to get financed and built at scale. We don't have decades to get them commercialized, we have years. This week, I spoke to Shreya Dave, the co-founder and CEO of VIA Separations, on the risk of going big. When the company faced two paths, scale up 10x or 100x, she made a decision to scale faster, and that put VIA in a race against time.
This is what people talk about. Climate tech is hard. This is what tough tech is.
Artificial intelligence is one of the biggest stories in energy right now, from the AI-based solutions for the grid to the unprecedented load growth caused in part by the AI boom. On December 3rd in Washington, D.C., Latitude Media is bringing together a range of experts for Transition AI 2024, a one-day conference on the AI energy nexus. We'll have networking, panels, a workshop, and technical presentations, and our podcast listeners get a 10% discount off their tickets. Use the code LMPODS10 when you check out. Head on over to latitudemedia.com/events or click the link in the show notes to see the full agenda and register for Transition AI 2024.
VIA Separations is named after the process the company is trying to reinvent.
Industrial separations are a process that exists throughout the manufacturing sector. So these make the raw materials that go into paper products, into plastics, into synthetic rubber, fertilizers. It's part of how we make the goods that are frankly foundational to our society.
Take a baby's diaper. Have you ever wondered how trees become the fluffy material that makes up your baby's underwear? Or even more importantly, have you ever wondered how much energy it takes to make one of those? Industrial separation is part of the magic. Making diapers involves turning wood chips into a mix of water chemicals and biomass, which need to get separated in a series of various steps. The problem is that certain parts of that separation involve evaporation, which takes a lot of energy.
So about 70% of the cost of producing a raw material or chemical is the separation step, and largely because of the energy that it consumes. We've been separating chemical compounds from one another using evaporators and distillation columns, which use industrial heat or steam, typically from fossil fuels, in order to heat a mixture up. The analogy I use is it's like a pot of pasta.
Let's explain this pot of pasta. So let's say you have a mill that makes the fibers that go into diapers. First, the mill takes out the usable fibers from the wood with heat and chemicals, and that leaves a big pot of useful byproducts like biofuel and chemicals mixed with water. That goopy mix is the pot of pasta.
Today, we boil off all the water to get to the pasta at the bottom of a pot instead of pouring it through a strainer.
So that sounds crazy because we all know that we don't actually make pasta that way. But this is essential to how industrial separations works today. For diapers, the remaining biomass needs to be separated into parts in order to make the process work. The chemicals need to be reused for the fiber removal process, and the biofuel needs to be used to run the mill. But separating out all of that extra biomass into parts takes a lot of energy. So instead of boiling off the liquid, Via Separations developed a graphene dioxide membrane, the pasta strainer, that removes water and skips a lot of that carbon-intensive evaporation.
Which at the industrial scale is 90% lower energy, fully electrifiable, and more modular and therefore demand responsive.
So a lot of industries, mining, pharmaceuticals, fertilizers, end up with mixes of valuable materials that they want to separate. Shreya and her team were looking for a way to extract them with a lot less energy. And that's what led them to develop a graphene dioxide membrane in the lab.
We came out of an academic lab at MIT with a concept and a very early lab stage proof of concept. We scaled that up to a place where we were in the form factor of what a commercial system would be like, but at a very much smaller scale and still working in the lab. We did our first field tests in the peak of COVID in July of 2020 at the first paper mill that we had really tested at, and we learned a lot about the pasta strainer or the membrane filter itself, but we also learned a lot about the balance of system, the pumps and the pipes and the things that were going to be required to deliver the whole product.
And this brings us to 2023, when Shreya had to make some hugely high-stakes decisions about proving commercial viability, including whether to scale 10x or 100x. Via spoke with several industrial plants that were very interested in retrofitting their separations processes to make them much more energy efficient. This included a paper mill run by International Paper, who happens to be a major manufacturer of wood pulp products. I talked with Shreya about finding her first customer, grappling with how fast to scale, and what she would have done differently.
We had the opportunity. We were looking at two different sites for this first-of-a-kind plant. I'll call them A and B, where we ultimately went with B. A was easier to get to. We had a longer standing relationship with that particular facility and the cast of characters. And B was far away and relatively new to us, and also incredibly enthusiastic and knowledgeable and a very well-run facility. And so those were the things that we ultimately decided on, was the individuals and the sort of corporate shepherding of a new technology was both very important to us, continues to be very important to us. I think an example here is when we were negotiating that contract, it was very explicit to all of us that this was a first commercial system, that this was the first, that we'd never done this before, that we'd never delivered a project before. And some might look at that and say, well, why are you admitting that? And the way we looked at it as, let's be honest and open and transparent from the get-go with the customer, so that when we hit a road bump, because we are all in the same boat together.
All right, so you got your one pilot. You haven't sold anything just yet to these commercial off-takers, but now you're ready. So what is the first set of decisions that you're aiming to make?
So we are thinking about, do we scale up? How far do we scale up? Do we do the classic chemical engineering 10x, or do we go to a full commercial plant? And we define commercial plant as having a material bottom line impact to our customer. And so the big difference between 10x and 100x here was that 100x mattered to the customer, and 10x was a step to getting to matter to the customer. We thought a lot about the engineering risk, the scientific risk, the financial risk across those two options.
So take me into the board meeting. We were discussing these options. What are the arguments on both sides of the equation? Because this is such a huge challenge that so many startups are having when it comes to this question around what they do next.
For context, our commercial pilot system had 2 racks of 6 membrane modules, and our commercial first-of-a-kind system has over 600 membrane modules. But the modules themselves weren't 100x. They were about twice as large. And so there wasn't a 10x or 100x question on the membrane modules themselves. There was absolutely a 10x or 100x question on the number of modules and then the engineering around it, the pumps and the pipes and the foundation and the weatherization and the control system. Those things were vastly different between the 10x and 100x. So when we're thinking about, in the boardroom, when we're thinking about things, we're thinking about, okay, in the success scenario, we go straight to 100x. We start generating revenue. We've proven both the technology risk retiring and the model, the business model with which we're selling to the customer. Or we hedge a little bit and take a 10x step on the way there. The 10x step, though easier engineering, was going to take just as long as getting to 100x because our lead time was defined by system components. When you purchase an electrical box or purchase a pump or purchase a component that has a long lead time, you can't deliver the whole system until after it comes. And so the lead time was the same for the 10x or the 100x because there are fixed costs that are there regardless of the scale of the project. So, for example, tie-ins for us are a fixed cost. Actually integrating into the customer, that is there whether you're doing a 10x or a 100x, regardless of the size. And so those fixed costs matter a lot more for a smaller system than they do for a larger system.
Let's also talk a little bit about the financial side of the equation, which, as you know, is near and dear to my heart. So you're here, you're ready to build a 100x scale-up factory. You've got a partner who's excited and willing to work with you. What were some of the alternatives that you considered around how to finance this commercial facility, and where did you wind up?
Yep. So how to pay for it was obviously very front of mind. We were at this position, so this would have been summer of 2022. We had raised our Series B the prior fall. So we had a bunch of cash in the bank, a lot of which was earmarked towards the first commercial project. But we did not want to use it all for the first-of-a-kind plant. And so I was kind of pounding the pavement, talking to early-of-a-kind funds. And what I learned was that the project finance that I had hypothesized was out there for first-of-a-kind systems was not. That those were truly and probably should be early of a kind. So maybe you're not meeting your full IRR expectations, but you're most of the way there. There's enough money to spread across the multiple parties. This project was not a good fit for that because we didn't have a full picture of the designs until we were very close to delivering. We didn't have the contract signed until 2 months before we broke ground. We did not have the finance capacity on our team to deliver project finance at the time. So there were a number of factors here. And instead, we started to look at things that were a little bit more corporate focus. So things like equipment loans, things like venture debt, things like additional equity. And that's actually where we landed. So one thing I should mention that I haven't mentioned is that a lot of our relationship with this customer, with International Paper, was thanks to a grant that we won from Natural Resources Canada, which really catalyzed the whole project. And so when we're looking to finance it, this was on the back of having won an award that we were executing on and that we were delivering on, but it wasn't enough to deliver the whole project. But it was very much a catalyst. And so some of the capital did come from grant, but the majority of the capital came from equipment loan and equity dollars.
Okay. And can you say what the breakdown was specifically around the grant versus all those other pieces?
Yeah, the grant was roughly 10-ish%, and then it was roughly a 50-50 split after that.
Okay. So now you're getting into the moment where you're building this project. Who is your engineering, procurement, and construction firm? How are you thinking about the decision around what you own and what you are contracting with others to provide when it comes to actually building and delivering the project?
Well, we decided to be our own general contractor so that we could stay very close to the engineering, the EPC, the engineering, procurement, and construction phases of the project. We did that for a couple of reasons. The first is because we wanted to be able to take those learnings for the future and be able to translate those into cost down, into optimization, into the data gathering that we were doing. And the second was because we did not have a partner who could do everything. There was no kind of one entity that both knew the facility and the customer and the ways that customer worked, as well as could deliver the things that our team needed them to do, as well as procure, for example, on the lead times that we required. So we did not follow the traditional FEL process for this first-of-a-kind system. We did much more of what's called a design build, and we did that intentionally for speed. We did that because as a venture-backed company, we have a burn, and delaying the construction of our project means that we are burning regardless. And this a little bit goes back to the 10x or the 100x conversation. In order to deliver a project like this, you need a certain number of skill sets. You can't necessarily contract all of those skill sets. And whether it's a 10x system that doesn't generate revenue or a 100x system that does generate revenue, we still needed to employ those people. And so your fixed costs are just very high. And as a result, we looked to speed. We did things to bring our lead time for pumps in by 18 weeks or 24 weeks. We did things that brought our delivery in by releasing design packages on an as-needed basis, as opposed to all of them complete up front. But that also comes with a downside. That does mean that you end up in a place where sometimes you have to do rework because you designed a package and then you learn something down the road and you've already done some of that build. And it also comes with the fact that because we did not work with one single EPC, we didn't have, nor did we have the designs, we didn't have a firm fixed price contract. So we were working on a time and materials basis with a number of different partners, all who contributed very important things to the project, which also left us as the sort of general contractor exposed to cost overages. And so it was, at the end of the day, our responsibility to navigate everybody's interests to get to a completed project. When you talk about all that stuff ahead of time, it's a lot easier. When you're talking about it in the thick of things, it's a lot harder. And as you know, Laura, I'll be honest, I had some moments where I said, are we going to finish this project? And how am I going to align all the parties that we have here?
Where are you going to be on December 3rd? I know where I'm going to be. I'm going to be in Washington, D.C. at Transition AI 2024. That's when Latitude Media is offering the chance to hear from experts on the front lines of AI deployment in the energy sector. Transition AI 2024 is our one-day in-person event, again in Washington, D.C. It addresses both sides of the AI energy nexus, the challenges AI energy demand poses for the grid, and the wide opportunities to help climate solutions. This is our third event, and we brought together a really great lineup for this year. It includes Meta's former Director of Energy Strategy, Peter Freed, DOE's Chief AI Officer, Helena Fu, Paige Crahan, who heads up Tapestry, Google X's moonshot for the grid, and AES Chief Product Officer, Chris Shelton, plus many more. And our podcast listeners get a 10% discount. Use the code LMPODS10, that's Latitude Media, LMPODS10, when you check out. See the full agenda and register today at latitudemedia.com/events, or just click the link in the show notes. I will be there. I hope to see you there. Transition AI 2024.
This brings us to the moment of doubt that we heard at the top of the show. Headed into 2023, VIA had the technology, the financing, the construction plan, but Shreya knew they had a very tight window to build literally just before the ground froze. And then the logistical challenges started.
So something we learned during the project was a lot about the local labor market. So, we talked about the location, how it was hard to get to and far away, but it is also on the edge of the Alberta oil sands. And as a result, it's very rural, and labor is more expensive than other projects that we were considering. We knew that, but we did not know to what extent until we were in process with the customer. So I think that was not an unknown so much as an area where the extent of the known was not complete. There are things you have to think about, like bringing folks in from the nearest city and making it worthwhile for the welder to come and be away from family and deliver good quality work, which means providing overtime, which is great for our timeline and less good for our budget. These are the very real aspects of the project delivery process that we didn't have time to do as a venture-backed company.
So people, so that was one thing. The location, in addition to being a place that was snowy, was also far away. So that was another thing that created some challenges for you, right?
Yeah. So just like any startup, our team wears a lot of hats, and many people from our team have spent many hours both traveling to and from, and also in the field at the site. It's far enough that when you go, you want to be there for a little while, but that also means you're away from your family and away from your routine and your day job, because that doesn't necessarily go away either. We knew this going in, and we decided to take a bet on the team here. But I would be remiss if I didn't mention the toll it took on our team to do all of that travel in the middle of winter. Winter means flight delays. That means that if we had folks on shifts and were relying on them to show up, then we needed to schedule a couple days extra on either side. That was a big feature of the project for our company.
And so was there a moment where you were asking yourself, is this going to happen, or is this all going to come crashing down?
Yes, but I think the question was, is this worth it? Is this worth the toll on the team? Is this worth the capital that we've raised? I can unequivocally say right now, yes. On the other side of it, I can unequivocally say that when it is successful and it is running and it is smooth and it is working and we have proved what we set out to prove, or at least the start of it, because time does matter. But I will say that there were moments where we look around and there aren't a lot of first of a kinds. There are very few climate tech companies who can say they're operating at commercial scale and that the customer is accepting the product. It's a lonely place to be the only one and not know what's on the other side in the thick of things.
Among the things that is challenging in this space is the financial resources that are available. And you really spoke to this eloquently around realizing that project finance and first-of-a-kind commercial climate technology installations are not necessarily compatible. I'll sort of post that as maybe my dramatic understatement of the year. What do you think is the right answer here? Because I think, part of what we see is that venture is potentially one way to get these things done. It is a way that things are getting done, but it's really challenging. It really does intertwine, your success with it as a company with your success at the project, and it's expensive to raise venture money. So what do you think do you have a sense for what is the right mix, or is there something else that's needed within the financial asset ecosystem that doesn't exist yet?
At the risk of putting the problem onto other folks, I don't think it exists yet. I think that there is an in-between project capital and straight equity capital that may have flavors of catalytic philanthropic capital or other debt products like equipment loans that wrap into a more diversified risk, so that it's not coming from any one single place. It's not a new concept. Obviously, that happens in project finance already, but I don't think that we have figured out the right ratio of those types of capital that makes sense for everybody yet.
Yeah, I think that's a really helpful comment. One of the things that's going around in my head is like, I think we're going to need some complex stacks of different kinds of capital to get these projects going forward. And the really big question is, which of these become repeatable, particularly across technology spaces?
I think that's right. And I think what's also important is recognizing that every first of a kind, not every single one, but many first of a kinds look different from each other. Carbon capture offtakes look different from cement plant offtakes, look different from, in our case, retrofit or brownfield project offtakes. And I don't know, though I think we are getting there, that we have the full vocabulary to speak about and then understand those various types of offtakes. I could be wrong. I don't spend a lot of time in other people's offtake agreements, but I do think that that's an element here, which is we are starting to build the vocabulary and the talking points, but we're not quite there yet because we've historically really only done solar and wind.
Okay, so you had talked, Shreya, about serving as your own EPC. What about in your next couple of projects? Is that something that you'll continue as a model, or is there a point where you see bringing in someone else ultimately to serve as kind of your general contractor or project manager?
There are pros to both. When we are closer to the engineering, I think there is more opportunity to value engineer and to make decisions that would otherwise be too far, too much at arm's length. But there's a lot of value to wrapping the project with an EPC and with leveraging the experience and the skill set and the buying power that an EPC has. In the near term, we are going to work with our customers to see which model or where on that spectrum is the best for them. That will depend on location. That will depend on their relationships with EPCs. And it will also depend on how we are selling the project and how quickly we are looking to deliver it. But we are very much open to and expect to leverage EPCs.
What did you learn from all of this? What is one thing, if you think about it, that you might have done differently?
One thing I would have done differently is recruited the project delivery team sooner. I think I made some assumptions about what the company needed in the moment versus what the company needed a year or 2 years from that moment, and could have kind of foreseen some of the project delivery aspects that made some of the challenges harder on the back end. I think if I would say one thing we did correctly was picking our partner. And I think that the fact that when things were hard, we could feel confident that we were also sharing that as opposed to hiding that. And I think that was a big piece of value. And then I got to say that also on the positive side, my co-founder and our CTO, Brent, is just a phenomenal source of truth, just a phenomenal beacon of why are we here? What are we doing? What are we delivering? And a reminder that this was going to work. We just had to get it there. And here we are sitting at more than 2,000 hours of operating data with a 0% yield loss. And he knew that, and that I knew that. Reflecting on it is a really cool thing.
That's incredible. So what comes next? What are your next couple projects?
Yeah, so we're scaling. We are taking the data and the lessons, but also the data from this first of a kind project. That is the biggest project we will ever build. So we're building a couple more projects that have larger capacity, but are lower in cost and footprint and all those sorts of things because they aren't first of a kinds. We're engaging with EPCs to do that. We're following the traditional FEL process because we know enough to be able to do that now, not know enough that it's a good process, but we have enough data that we can design based on that process. And you'll see us at your neighborhood pulp mill in the near future.
Shreya Dave is the co-founder and CEO of Via Separations. The Green Blueprint is produced by Latitude Media in partnership with Trellis Climate. The show is hosted by me, Laura Pierpoint. Our producers are Aaron Hardick and Daniel Woldorf. Ann Bailey is our senior editor. Sean Marquand is our technical director. Stephen Lacey is our executive editor. If you'd like to suggest topics or guests for the show, send an email to editorial@latitudemedia.com. You can listen to The Green Blueprint at latitudemedia.com or subscribe wherever you get podcasts. And if you have fellow clean energy or climate tech travelers who would benefit from the insights in this show, send them a link. This is The Green Blueprint, a show about the architects of the clean energy economy.